Let's solve this challenging integral step by step. We need to evaluate the integral of dx over sine x plus b cosine x. The key to solving this integral is to make a clever substitution. Let's let it equal our cosine alpha and b equal our sine alpha, where r is equal to the square root of a squared plus b squared. To understand this substitution better, let's look at it geometrically. We can think of a and b as components of a right triangle, where r is the hypotenuse and alpha is the angle. Using this substitution, we can rewrite the denominator. A sine x plus b cosine x becomes r times the sine of x plus alpha. This allows us to rewrite our integral as 1 over r times the integral of dx over sine of x plus alpha. The integral of 1 over sine is the natural log of the absolute value of tangent of x over 2. This is a standard integral we should remember. Therefore, our final answer is 1 over r, which is 1 over the square root of a squared plus b squared, times the natural log of the absolute value of tangent of x plus alpha over 2 plus c. This is a beautiful example of how a clever substitution can transform a complex integral into one we know how to solve. The geometric interpretation helps us understand why this substitution works.